Hi. So in this module, we will understand whether an amplifier can be used as a comparator. So as stated in our previous video module that any high gain amplifier can be used as a comparator. We said that. But there are a few points that we need to understand here, and we are going to discuss here. In what situations you can use an amplifier as a comparator and in what situations you may not. So when we talk about amplifier used as a comparator, we are talking about a differential amplifier, specifically an operational amplifier, because the comparator, as explained in our previous modules, the working principle states that it has two inputs. One is the input signal coming that needs to be compared with another reference signal. Okay, and accordingly we have, we have two inputs, therefore we need a differential amplifier. So now we say that use an amplifier as a comparator if you want to have a low offset and drift. What is the offset? Offset voltage is that you have a differential amplifier, as you can see that. So offset is a minimum difference voltage that you must apply between the two terminals of the amplifier to nullify the output, to set the output to zero. So that is input output, that is offset voltage. So low bias current, if you require, then use amplifier as a comparator. And of course, cost and area. For example, in a market, you go and buy an operational amplifier IC, you have basically quad APAM. So quad means there are four individual operational amplifiers in one IC. So let's say two or three operational amplifier you used as a linear application, for example, amplifier or filters, etc. The remaining one operational amplifier, if it is unused, so obviously it is costing you area and the cost. So why not use that amplifier as a simple comparator? However, you cannot and do not use amplifier as a comparator because amplifiers usually have lengthy recovery time from the output saturation. So if you are using amplifier, for example, as shown in this image, as a comparator, it is switching between the two levels, saturating to positive and the negative levels of the output, high level and the low level. So it has a lengthy recovering time from the output saturation. So from one level to another level, it takes time to switch. And that is the reason. Another reason, it has a long propagation delay. So obviously the operational amplifier output stage is internally compensated through the Miller capacitance or any amplifier, so that makes the bandwidth less of the amplifier, and they are usually slower in speed, so that means long propagation delays. Of course, the amplifier has an inconvenience of making their output compatible with digital logic. So if you use amplifier as a comparator, it is generally inconvenient to use their output, which is switching between the two levels, to drive the digital circuitry. And dynamic stability is also a concern, again, because there are internal capacitances, that is a Miller capacitance. But in a dedicated comparator IC, we don't need a compensation capacitor. So usually they are faster. So in conclusion, we'll say that amplifiers are slower. This is due to because they use internal compensation capacitor or Miller capacitance, which is usually the output stage of the amplifiers. And comparators are faster. Why? Because they do not need an internal compensation capacitor. So you need to remember that. So we continue our talk. So if, for example, your input signals, that signal you need to compare, they are slowly varying or DC signals. They are a low frequency signal or DC, then at that time, amplifier to be used as a comparator is a choice. Or of course, again, if you have input signal that is noisy, so you can use amplifier as a comparator, because amplifiers are more noise prone as compared to comparators. Comparator are more noisy. So comparators have relatively large noise and offset, as I said here, and in some application with slowly changing inputs, noise will cause the comparator output to slew rapidly back and forth. So if you use a comparator for a DC applications or low frequency input signals, so noise can cause a problem because your output will slew between high and the low level. So in that case, amplifier is a good option. So finally, the statement, if the application requires comparison of the signals in less than a microsecond, so it's quite fast. You want high speed results, high speed output, the comparator is a must. Then in that case, you cannot really use the amplifier as a comparator. But nowadays, with the high precision, wide bandwidth, low offset, ultra low offset amplifiers from various vendors in the market, they are competing with the comparators. So as a designer or as an application engineer, you need to choose, have all these parameters into mind, such as drift, offset, cost, area, speed, and all those things, and accordingly make your choice. So earlier I said the comparator is a circuit which compares the two signals. Okay, these signals have different magnitude, and you have to compare which one is greater or smaller. Okay, so we are basically done with this, and we'll see more topics such like that. Stay tuned.